Hi, this is Karen O'Brien, and we just finished showing you how to create the project recovery or the backup file. And now we're going to move on to Lesson 1, Part 3, Hydrology, where we will add rainfall, infiltration, and a inflow hydrograph to our project area. So let's go ahead and start with the location of the data. So now Lesson 1 folder, the hydrology folder is here, and I think we also need this inflow.dat file right here, and the hydrology data is here. So let's go ahead and start. Let's see, so we need a rainfall distribution curve. This is a depth area reduction. No, sorry, this is a rainfall depth reduction raster, a land use shapefile, and a soil shapefile for green and amped. If you want to use SCS, there's other advanced training modules that use SCS down below. And the steps will be to open up QGIS, which we already did at the end of lesson 2, so we can just skip that one. We already loaded lesson 1. We will want some aerial images, assigning inflow, assign rainfall, assign infiltration, check our control variables because we have 2 switches we may need to turn on, save the project, export it, and then run it. And this project will have water, so it will be an official run that can be used down the line to review the model, which I will give us another file called QGIS Lesson 1 Part 3 Export. And that way we won't overwrite what's currently there. We can look at the difference between the two in a review video. Okay, so we already did that. And import the aerial images. So what we have in here is this Quick Map Services. You were taught how to install this plugin in the video for setup video. And if you couldn't get the contributed pack or you had some problems with that, contact me for technical support because I have all kinds of different ways to get these loaded onto your computer so that you can use these maps. For now, if you didn't get them, you can just grab these aerials in here and use them instead. So I'm just going to click this button right here with the plus symbol on it. And I limited all of mine in the search settings. In the visibility, I limited all of mine to just the Google Maps. So that's why you only see Google Maps when I click that button. And I want the Google hybrid. Google is the satellite with the road labels, and the Google satellite doesn't have any labels. So either one of those is fine. I like the satellite one because it's not quite so distracting. That's his information here. If you don't have an internet connection, you can use the aerials images. And if you don't see that Google map, you need to follow this step right here. All right, so we're going to zoom in on our basin inlet feature and add a boundary condition point to a location where water would be crossing our grid. And we will then save that data into the widget and click OK to close the button, or click the OK to close the message. And then we will set that to inflow, name it, give it some hydrograph data, or name the hydrograph, and then open the hydrograph file using Notepad. Control A will select all of the data. Control C will copy all the data, and Control W will close the file. And then we'll put it into our Flow2D table editor and click the paste button, and then schematize that to commit the data to Flow2D. So that's all step 4. And again, like I said, if you want to come over here, you can bounce back and forth between these steps really quickly over here. I'm also going to turn this off now because we'll need some of these images get a little fuzzy if you don't give them a bit more space. I'm going to minimize this, and we'll zoom. So project that the image told us to zoom in up here, and as you can see, what we have is all the water coming down to this drainage is going to enter or cross our boundary right here at a big culvert. So what we're going to do is we're going to, all of that water that was calculated from a different project, I converted into a hydrograph, and I'm going to put that right inside here. So I'm going to click this guy because I just want to always collapse all groups before I change to another group, then open the boundary condition editor. This is a widget. Each one of these are widgets, and always collapse them before you move to a new one. Don't leave a bunch of them open. I'm going to click on the dots because I want to do a point inflow, an inflow point, not like a polyline or polygon or anything. It's going to be an inflow point. And then I'll click anywhere inside the boundary, but I typically always put it right here. And I'll click, and that automatically is set up to inflow. And I'll click OK. And then back over here, save, and click this. Just let me know that it updated it. Click OK. And then we can start naming it. So I'll click the little naming icon, and this is the Grover Basin. So let's call this Grover in. And it does have a time series. So if I select it, it will, I don't know why it's got some blank data in there, but we'll be overwriting that. We will be filling out the time series data from the data that's provided in the project folder. So back here in lesson 1, we have this Grover in 24-hour 100-year hydrograph in a text file. If I open this, I'll show you on the left is time, on the right is discharge, and it is tab delimited. I'm going to click Control A, and that is going to select all of the data, including the very last line return. That's important. Control C will copy it, and Control W will close the file. I'm going to show you that again. Open it up, Control C, A, W. I did that backwards. Control A, C, W. You don't have to let the control button up. It's just a simple thing. You hold the control button down and you type A, C, W. And now it's in your clipboard, and you put your cursor right here, make that cell blue, and click paste. And then you can see it comes right in there. We don't have any mud in this one, so it's just clear water. Back over here, we can name that. This is the Grover in 100-year, 24-hour inflow hydrograph. And then we can click this guy, and that will commit it to Flow 2D. So 1 inflow and 0 outflow boundary conditions were schematized. And now you can see that it has the whole grid was assigned that inflow hydrograph. And inflow hydrographs, something important about them, I don't know, there's a limit to the amount of data that you can use. So please don't try to load like 1,000 rows of data or some ridiculous number of data. Just keep that like around, maybe 300 should be your limit. I'm not sure what the official limit is. I think it's 1,000 or 3,000, but that's just too much data. You don't need that. Okay, I'm going to zoom this back out to our full map, and we're ready to move on to the next step. So step 4, add an inflow node. Step 5, assign uniform rainfall. So collapse your Flow 2D icons by clicking this guy, and then expand the rain editor. And then we will click Simulate Rainfall, add 3.74 inches of total rainfall. Check the building rain switch, click the import icon right here, and you will be importing an SCS 24-hour type 2 rainfall pattern, and that will load automatically, and it will assign a uniform rainfall to every cell. So collapse here, rain editor here, check that to turn on the rainfall. This is your total storm in inches if you're using the English units, and if you're using the metric units, that will be millimeters. The total value is 3.74 inches of rainfall, and we'll do building rain. So when we put our buildings in, the rain will rain onto the buildings and rain off of them. If you don't check the rain building switch, the rain will rain onto the buildings and that will be a sink. So they will not leave the buildings. But that'll be the buildings, I think, come in like lesson 4. Now here is our time series. So what we want is this guy. Click the open and then come over here and get the, where is it? 24-hour type 2. Oh, sorry. It's in the rainfall distributions are in a couple places. It's in your Flow2D Pro documentation, or it's in this hydrology file. And I think the instructions tell you to use this one, and that's perfectly fine because they're the same. So I'll just grab this one and click OK and click OK again. And you can see that what we have here is time on the left in hours, percent total on the right in storm drain, and the percent total does not go from 0 to 100%. It's a decimal value, so it goes from 0 to 1. So just recognize that. That's how most percentages in Flow2D work. They're not like 100%, 0 to 100%. They're 0 to 1 because they're typically applied as a factor. Okay, so now what we have is just uniform rainfall on every single grid element. Now, if you had a larger watershed and you wanted to apply a depth area reduction value, I'm going to show you that method here. So here you would click the spatial variation with depth area reduction and grab the, oh, sorry, let me show you this is step 6, apply a depth area reduction. Or you'll grab the depth area reduction raster, which comes from NOAA Atlas 14, and click the button, or click the checkbox and then click the button to pull up the calculator, which is the warp tool. It's the exact same warp tool we used for elevation. Okay, then we'll do that. So we grab that data and we drag it and drop it onto our map. And what this is the depth area reduction for the whole state. So you can see that depending on where you are, you get a different rainfall value. And what this will do is it will give you a factor of the rainfall value on the cell, which will become a percentage of the total rainfall value. So this works okay for smaller watersheds. Our watershed is kind of funny because it's so small that it's mostly uniform rainfall anyway. But this, let's get this down here. But if you applied it to a much bigger a much bigger watershed, you might have to do this in terms of subwatersheds, because you might have like a total rainfall is going to change kind of depending on what area you're modeling and what watershed you're modeling. So your total rainfall might be like the total rainfall, not the total rainfall of one specific point. So do be careful about that, and do follow your hydrology guidelines when you're setting up hydrology for Flow2D. Let's go ahead and zoom back to the computational domain. I'll click right here and just zoom to that. And then back over here, we can click, let's see, back over here, we can click this guy, the AR button, set that to the new raster, put, again, it's the same thing, the -9s. It doesn't honestly matter. Whoops, sorry, that's supposed to be -9999. And I don't know, I go for like a maximum of all known non-data pixels to get like that maximum rainfall value, and then click OK. And that will calculate a fraction for every cell. Of course, they're going to be mostly close to 9 because, or 0.9, because all of our grid elements are, because our project is so small, there's not much spatial variation in the depth area reduction for that map. So we're not going to get much depth area reduction. But if we had this kind of like this project up like on the Mogollon Rim or something, there'd be a lot more variation on the project. Okay. And that is basically done. We don't have anything else to do to simulate rainfall. It's done. So the next step is to go ahead and do the infiltration. So this is the method I'm about to show you, is the method they use for the flood control district of Maricopa County, which uses pretty extensive and detailed land use polygon shape files that are full of imperviousness and whatever values. We can open them up and see what they are. And of course, the soil shape files that have your infiltration rates and other forms of imperviousness and a soil depth. And let's go ahead and just apply these now, and we'll take a look at these fields and how to get this information. So I'm going to minimize that. We need the two new layers. So I'm going to center my map, and I think maybe I can just go here in my project data and just select the group. I'm going to turn everything off except the layers that I want. So the key is to activate the group so that when you drag data and drop it on the map, it goes here. Otherwise, sometimes you might lose it. If you put it in these layers, you might lose it. And then I'll get from the hydrology folder, I'll get the soil and the land use shapefiles and drag those onto the map. And you can see here that the land use shapefile is the very detailed with all the impervious areas related to buildings and parking lots. And the soil is your standard NRCS soil layer, or I think it's NCLD or soil layer, whatever it's called. It's pretty standard. So let's start with that one. Open the attribute field. You get the rock outcrop is 0 to 100. Effective is 0 to 100. This is an effective impervious, rock outcrop impervious, and a soil depth, which is a limiting depth. So to reduce infiltration on an area that has a limited depth for whatever reason. And the XK-SAT is the hydraulic conductivity. For the land use, we have initial abstraction, R-temp, which is the impervious area, vegetative cover, initial saturation condition, which will be dry, normal, or wet. You don't need that, and you don't need those two. That's just data that we use to test N values on this particular map. And I'm going to close this now. And note that the R-temps on the input data is 0 to 100% impervious, and the R-temps in the flow 2D data is like a decimal percentage. Okay, so close that, and then we go here, collapse everything if you haven't already, go here to the infiltration editor, and the first thing you need to do is to go to global infiltration, because that will allow you to choose what kind of infiltration you're going to use. So we're going to use the green amped, and I'm going to leave these default values in place because all the values I'm going to calculate will supersede these, but you can set them to whatever you want. And then I'll click OK, and that will open up some more fields for me. I don't need to do anything with these fields, but I do want to hit Calculate Green Amped. And when I hit my calculator, it fills the fields automatically because I've already done this before. But you're not going to see that. So what you're going to want to do is set the soil layer and its corresponding fields, rock outcrop, effective impervious, and the soil depth field. This is feet meters. This is 0 to 100%, 0 to 100% inches per hour or millimeters per hour. Then you'll choose the land use layer out of the list of layers, and initial saturation, which is wet, dry, or normal. I'm not going to use vegetative cover because the Maricopa County does not use a vegetative cover field. Initial abstraction, and then the R-temp for that field. And then you just click OK, and it's going to intersect the land use layer to the grid and calculate a weighted average of all the land use fields for a single cell. And then it's going to intersect the soil layer to the grid, and it's going to calculate all of the weighted average of all the soil data for a single value to every grid. And I'm going to show you what it gives you in just a second as soon as it's finished calculating. Now, when it's finished calculating, you're actually done with these two layers, so we can turn those off. And as you can see, our map got a lot darker, so there's another layer that's been filled, and that is right here. This is our schematized infiltration layer. And if I open it and I right-click green amped areas, areas green amped, and I click open attribute table, I'll show you what's in here. Now, don't forget that if you do this, so what the calculator does is it takes all those values from the land use and the soil layer, but it calculates them into the actual values that the green amp uses, which is hydraulic conductivity, soil suction, d theta, soil depth, initial abstraction, and percent impervious. And you can see the percent impervious is 0 to 1. It does not go above 1. And I don't know, I think my soil depth is all the same. And then you can check, you can do this by clicking this name, field name, to sort your data and check it for invalid data. So you don't actually need all those other values from, you can actually create your own polygons with these fields and just schematize it to the map. And I'll show you how to do that right now. So if you didn't have that fancy data like these two, you can go into this user layer. I'm going to turn this off. You can go to this user layer, infiltration areas, and you can make polygons for your different soil groups and your different land use categories. And you can just make these polygons with the data that you need. See, it's only, let's just skip out this one. Let's just do from here, hydraulic conductivity, soil suction, d theta, initial abstraction, r temp. Now watch what happens if I click this guy right here. Then I can come up here to an area that would have, say, like infiltration. Let's say this area right here. And I know the soil condition of this area. And then I right click that. I know the soil condition of this area. And I can click save on that. And then I can put those values from that I want, the soil moisture deficit, hydraulic conductivity, impervious area, and the capillary suction, rainfall abstraction, and the soil depth here, and then it will be applied to that polygon right here. And you can build as many polygons as you want, but you don't have to get crazy like these shapefiles down here, because this is just a different method by a different engineering county method that goes extreme on the detail. And you don't have to do that to get a good model. You just, you do want to get that impervious area if you're doing urban, but if you're not, infiltration is not that difficult to set up. So I'm going to remove, I'm going to open that up, or here, let's just delete it. Just go here and just click delete, and it'll just delete that current layer. And I don't have to mess with anything. So the data, so until now, if you do it that way, the last step you need to do is run the Schematized tool. And don't forget, the global variables are there as a catch-all. So if I had my global variables set up to, like, say, a baseline infiltration, and then I just wanted to account for like the extra imperviousness or something, then I could just put polygons in here to represent big impervious areas and give them an R temp equal to like half or 0.5 or 1 or whatever. So that about sums up infiltration, and we are basically done with that group of data. And you don't have to turn this on. You can just leave it off because you only have to do infiltration once. It's kind of done. And then come up here and we can minimize these guys, and let's just see what we did to finish this up. See, we choose our infiltration groups, and then we set up our control parameters, which the only thing that should have changed of these, save the project, export the data, and then run the model. And that is the end of this lesson. So I'm going to minimize this, go here. The only thing I'm checking, nothing should have changed. So that's fine. That's fine. And just check, make sure that these two buttons are checked, save. And then I click export, and I want this one to go into the new export, select the folder. And now you can see the rainfall doesn't have those stars next to it because the data's filled. and just click OK. Now, why didn't I create a downstream boundary condition? Well, I'm going to do that in the next lesson, but what I like to do with Flow2D, my first run, I just like to run it and see where the water is going to pool against the boundary, and that will tell me, do I need a bigger model, or do I need where do I need my downstream boundary condition to be defined? And so that's why I didn't put in a downstream boundary condition. So we're done. We click Save. We close it, and then make another backup, and this one we'll call Lesson 1, Part 3, OK. Now this one should be a bit bigger because we added quite a bit of data. Where did it go? Right here. So Lesson 1, Part 3, OK, or Part 3 complete, whatever. Yeah, it's a little bit bigger, not a whole lot bigger. And this is the end of the video. So the next step will be going into Lesson 2 to add the channel.